In engineering, scientists don't use degree measure when they're measuring angles. There's a more exact measurement system. It's called the radian. Now, we're going to discover in a separate project exactly what a radian is. So for right now, I'm just going to give you the definitions. Remember when you learned circumference of a circle and they told you the circumference was pi times the diameter, or because the diameter is twice the radius, it was 2 pi r? Well, there's a significance to this 2 pi part. And the significance is that 2 pi radians is the equivalent of 360 degrees. That means it's a full circle in a new unit of measurement called the radians. Well, if 2 pi radians is 360 degrees, if you divide both sides by 2, you find out that 1 pi radian is 180 degrees. We're going to use this fact to convert between degrees and radians and between radians and degrees so that you can start to learn this new unit of angle measurement. Now, I do want to tell you what happens if you divide both sides by 2 again. If you divide both sides by 2 again, you find out that pi over 2 radians is the same as 90 degrees. We could keep doing this all day. If I divide both sides by 2 again, pi over 2 divided by 2 is pi over 4. That's by using our properties of fractions, which is dividing by 2 is the same as multiplying by the reciprocal. And you would find out that this is the same as 45 degrees. So using those definitions from the previous page, we're going to define 1 radian to be 180 divided by pi degrees. And 1 degree is going to be pi divided by 180 radians. Now, I want to give you a reminder. You probably know from geometry that pi is approximately 3.14. That's going to come back in a few when we learn about decimal radians. I'm going to show you 2 different ways of doing example 1 here, and you're going to decide which one makes the most sense to you, and that's what you're going to stick with. So in example 1, we're going to change 115 degrees into radian measure in terms of pi. A lot of times we like to do radian measure in terms of pi. There are circumstances under which we don't. So here's one method of doing it. Since I said that 1 degree is pi over 180 radians, you can take 115 degrees and multiply it by pi over 180. When you do that, because this is over 1, you get 115 pi over 180. And then in your calculator, you're going to take this part of the fraction, the 115 over 180, and you're going to reduce it. The way you reduce is that you type in 115 over 180, math, enter, enter. And it's going to reduce to 23 over 36. So it's 23 pi over 36. And this is called the exact radian measure. Now, here's the other way you could attack the problem. A lot of times you're used to proportions. We do proportions all the time. We do proportions with the law of sines. We also are going to do some more work on something called dimensional analysis. So we know that 1 pi is equal to 180 degrees. So if you want to find out the radian measure of 115 degrees, you could set this up as a proportion. Now remember, when we do proportions, you've got to keep your units consistent. So if I put radians in the numerator of the first fraction, radians must be in the numerator of the second fraction. So when I cross multiply, I get 180x is equal to 115 pi, and then I divide by 180. I still have to reduce it, but that's another way of attacking the problem. All right, let's do this again. How about if I want to go from radians to degrees? So I'm going to change negative 7 pi radians to 1 degree. Well, we know that 1 radian is 180 over pi degrees. If I multiply these, I want you to notice that the pi's are going to cancel. And I'm left with negative 7 times 180 over 8, which is going to be negative 1260 over 8. Negative 1260 divided by 8 is going to be negative 157.5 degrees. Now the other way you can do it is you can go back to this proportion where you've got pi over, or radians over degrees is equal to radians over degrees. You end up with the same answer because you're going to get pi times x is equal to 180 times negative 7 pi over 8. Now notice that I'm not plugging pi into my calculator. I'm not converting it to 3.14. I'm leaving the actual Greek letter pi in my answer. So what ends up happening is you get this. The pi's cancel, and you're still going to get this answer when you're done dividing. A third way of actually doing this particular problem, not A, but B works this way, is if you remember from the previous page that I said 1 pi was 180 degrees, the way that I do the problem is I just replace pi with 180 degrees, and I still end up with negative 157.5. The next thing that we're going to do is we're going to go back to our unit circle. We filled out most of the unit circle, but the only thing we haven't filled out yet is the radian measure equivalent of these degree measures. Now, there are some things we already know, like we know that 360 is 2 pi because we established that at the beginning, and that 180 is 1 pi. And then if 2 pi, let's try that again. If 2 pi was 360 degrees and I divide by 2 and I get 1 pi is 180 degrees and I divide by 2 again and I get pi over 2 is equal to 90 degrees, this means that this is pi over 2. Think about it like half a pi, because here's 1 pi, so 90 degrees must be half a pi. There's actually a pattern to how the multiples of 30 degrees and the multiples of 45 degrees work in the unit circle. So we're going to start with the multiples of 30 by converting 30 degrees into radians. So I change 30 degrees into radians by multiplying by pi over 180. I get 30 pi over 180, and 30 over 180 reduces to 1 over 6. So 30 degrees is 1 pi over 6. If you go another 30 degrees, you'll be at 2 pi over 6. If you go another 30 degrees, I'm going to take this out of my way because I'm going to run out of writing space. If you go another 30 degrees, you'll be at 3 pi over 6. If you go another 30 degrees, you'll be at 4 pi over 6. And then another 30 degrees will be 5 pi over 6. Another 30 degrees you'll be at 180, which is 6 pi over 6. Then you'll be at 210, which is 7 pi over 6. And then 240 is 8 pi over 6. And then 270 will be 9 pi over 6. 300 will be 10 pi over 6. 330 will be 11 pi over 6, and then 360 will be 12 pi over 6. So every time you go 30 degrees, you go another pi over 6 radians. The thing is that a lot of these radians can be reduced. Like 2 pi over 6 is going to actually reduce to pi over 3. 3 pi over 6 reduces to 1 over 2 pi. Well, we already know it's pi over 2. 4 pi over 6 reduces to 2 pi over 3. 5 pi over 6 does not reduce. 6 pi over 6 reduces to 1 pi. 7 pi over 6 does not reduce, but 8 pi over 6, 8 over 6 reduces to 4 over 3. 9 pi over 6 is going to reduce to 3 pi over 2. 10 pi over 6 reduces to 5 pi over 3. 11 pi over 6 does not reduce, but 12 pi over 6 reduces to 2 pi. So there's a nice little pattern if you can remember that 30 degrees is 1 pi over 6. Every additional 30 degrees is another pi over 6. So then, after I wrote all the pi's over 6, I reduced the fractions that could be reduced. So let's go back again. So remember that 90 degrees is half a pi. 270 is 1.5 pi, because you've gone a pi and another half. Well, because 3 over 2 is 1.5. Now we need to go back and talk about the multiples of 45. So let's change 45 into radians. I actually did this earlier because when we found out that pi over 2 was 90 degrees, I said if you divide it by 2 again, you get pi over 4 is 45 degrees. However, you can also do it the new way we did it, which is you can multiply 45 times pi over 180, and you get 45 pi over 180, and 45 over 180 reduces to 1 over 4. All right, so now we know that 45 degrees is 1 over 4. So if you go another 45 degrees, you're at 2 pi over 4. If you go another 45 degrees, you're at 3 pi over 4. Another 45 degrees, you're at 4 pi over 4. Another 45 degrees, you're at 5 pi over 4. Another 45 degrees, you're at 6 pi over 4. Another 45 degrees, you're at 7 pi over 4. And another 45 degrees, you're at 8 pi over 4. Any of these purple fractions that can be reduced should be. Well, 2 pi over 4 reduces to 1/2 pi, so I just get the same answer again. 3 pi over 4 doesn't reduce, but 4 pi over 4 reduces to 1 pi. 5 pi over 4 doesn't reduce, but 6 pi over 4, 6 over 4 reduces to 3/2. 7 pi over 4 doesn't reduce, but 8 pi over 4 reduces to 2 pi. So these are the radian equivalents of the degree measures. We're going to work more with these patterns so you can start to memorize them to go along with your unit circles. Now the other thing is all the ordered pairs that we've already put at these angles on our unit circle are the same ordered pairs whether you're working in degrees or radians. If it helps you to work in degrees, you should. I even recommend sometimes to students that if they're having a hard time with the radians, if you convert it back to degrees, it may help you out a little bit. So now let's go back and talk about finding exact angle measurements of trig functions, except this time working in radians. When we want to find an exact value of a trig function, not what you get when you plug in your calculator, but an exact value, then you need to identify something called the reference angle. So I'm going to show you a couple different ways of attacking this problem. One way is if you're not sure where 25 pi over 6 is, because you need to know if it's in quadrant 1, 2, 3, or 4, so you know the answer should be positive or negative. But what you can do is you can convert it back to degrees. Remember I said earlier you can just put in 180 for pi because 1 pi is 180 degrees, and then multiply 25 times 180 divided by 6, and you find out that it's the same as 750 degrees. Except 750 degrees is not between 0 and 360, so I'm going to subtract 360, and I'm going to find out it's 390, which is also not between 0 and 360, so I have to subtract one more time. And what I'm going to find out is that 25 pi over 6, which is 750 degrees, is coterminal with 30 degrees. That means that they're in the same location. That means that it's in quadrant 1. If you use the hand trick to find the ordered pair for 30 degrees, you should get the square root of 3 over 2, comma 1/2. Remember the ordered pair is cosine of the angle, comma sine of the angle. If you flip your hand over, you'll get the tangent, and the tangent is 1 over the square root of 3. which is square root of 3 over 3. Since it's in quadrant 1, everything's positive. Now there's another way of doing this problem, but it's going to take some work for us to do a little bit of memorizing. The nice thing about radians is that determining what their reference angle is always really easy. Maybe it's not easy figuring out what quadrant it's in, but at least we can find its reference angle. So if we look back at this circle for a minute, I want you to notice that 30 degrees was pi over 6. I want you to notice that 150 degrees is 5 pi over 6. 210 is 7 pi over 6. 330 is 11 pi over 6. All four of those angles have the same reference angle of 30 degrees, and they all are something pi over 6. That means that the reference angle is pi over 6. So if you can figure out that the reference angle is pi over 6 or 30 degrees, and you can figure out what the ordered pair is, you can use your hand trick and then flip your hand over to find out that's 1 over the square root of 3. The other way of doing it is tangent is also equal to sine over cosine. So 1/2 over square root of 3 over 2 leaves you with 1 over the square root of 3. So let's talk a moment about reference angles. If you have an angle like 4 pi over 3, its reference angle is going to be pi over 3, which is 60 degrees. If you have 11 pi over 6, its reference angle is pi over 6, which is 30 degrees. If you have something like 3 pi over 4, its reference angle is going to be pi over 4, which is 45 degrees. The reason that's important to know is because if you know what the reference angle is, you can use the hand trick to find the cosine and sine of those angles. Now let's talk about coterminal angles of angles in radian measure. When we did coterminal angles of angles in degrees, so for example, let's say I gave you 1080 degrees and I said, find its coterminal angle between 0 and 360, you kept subtracting 360 until you got an answer that was between 0 and 360. So if I keep going, I had to subtract 360 a couple of times before I found out it was 30. But in radians, 360 degrees is the same as 2 pi. So what I can do is subtract 2 pi. Now, we're going to use our calculator to help us out. So ignore the pi and just do 25 over 6 minus 2, and then hit math enter, and it'll change it back into a fraction for you. It'll give you 13 over 6, and all you have to do is put pi there. Now, if we go back to our circle over here, one of the things we ran across is that 2 pi was the same as 12 pi over 6. So anything bigger than 12 pi over 6 is still not between 0 and 360. So I have to subtract 2 pi again. And again, you're just going to subtract 2 from the previous answer, hit math enter, and then it'll tell you it's 1 over 6, which is 1 pi over 6, which is 30 degrees. Now, do you have to do it this way? No. One of the things we're going to recommend you guys do is change your radians back into degrees so that you can practice with your reference angles and coterminal angles and your hand trick for finding exact values of trig functions at any of these angle measurements. And we're going to call this angles in radian measure, we'll call it part 1.